Hello class, this is Andy, and on the other side of the camera is Kyle. We're doing number 5. This is number 5. We got a quarter circle, and we're trying to find the electric field right here. What is that electric field? So let's start with the electric field equation. You have E equals KQ over R squared. Just a note on this K thing, you're probably going to see this a lot. No, you are seeing this a lot. You don't need this yet. You'll use that much later in this class. So, ta-da. Anyway, we're going to go with this. And we want the electric field of this entire Q. But the electric field is changing as the angle changes. And it's just, you can't just, it's not a point charge, you know, it's a line charge. We're treating it as a line charge. So, let's say dE equals K dQ over R squared. Now we're looking at this Q right here, this little part right here, that's, oops, little q, dQ. That's a dQ right there, and we're, oh, wow, that's supposed to be a pi section. Yes. So we're looking at that. We only want, let's see, how do I simplify this? So the electric field is pretty much going to be in this line. It's either going to be going this way or going that way, depending on whether Q is positive or negative. This stuff is going to cancel out. So we only have this. So I'm going to shift the axis, because I can do that. We don't need that anymore because I just redrew things. Now you have a quarter circle. I don't know if you can see that. Let me draw it in green. Now you have a quarter circle. Oh.
Blue's better.
Now you have a quarter circle on the bottom. That's a quarter circle, I promise. And we're trying to find the E field right there. Now we can say all of the electric field in the x direction cancels. Pretty cool. Now we're just concerned with all of this. So what is this? What is all that? Because we have a bunch of these that are doing this, and we're going to add up all of the y components to this.
Because all the x components cancel out.
Yeah. So we're going to add up all the y components. And so I'm going to blow this up for you. Here's the origin, here's EY, here's E, and here's EX, and here's theta. Theta is going to be changing depending on where you are on this quarter circle, and that means EY is going to change. So we want DE in terms of d theta, but not just yet. Since we just want this, we were going to multiply this by sine of theta to get only the y components. Okay, so now we want Q in terms of theta so that we can get our d theta out here, right? So dQ is to d theta. So if we look at this change in angle versus the change in charge, we're going to say the total charge over the total angle, which is pi over 2, or 2q over pi. So now we can say, let's pull this down, we got dE equals 2kq over r squared, pi r squared, my bad, times the sine of theta d theta. Because we saw for d right, or dq right here, we pulled this back over here, got d theta. There we go. Sorry, I skipped a step. So this is the equation we got to work with. That doesn't make really much sense until you can plug it into a calculator and work with it. So let's integrate the crap out of it. Let's put some limits on it. Since it's a quarter circle, we're going to go from 0 to pi halves. That still works even though I've changed my coordinate system. It's just fine. So this becomes E. Get E equals, this is all of this right here. That's constant. So 2kq over pi r squared integral from pi halves, 0 to pi halves of sine theta d theta. That's 1. So that's our answer. Our symbolic answer is E equals 2k q over pi r squared.